Myself, I am Dr. Rajendra Konda from Srimati Veeramangangasri Degree College for Women, Kalburgi. So today we will discuss regarding the D flip-flop and T flip-flop. A D flip-flop has two inputs, a clock and a D input, and two outputs. They are Q and Q bar, and which are complementary to each other. It's constructed by modifying the SR flip-flop. The S input is given with the D input and R input is given with the inverted D input. Hence, a D flip-flop is similar to SR flip-flop in which the two inputs are complemented to each other. So there will be no chance of any intermediate state that occurs. So this is the block diagram and this is the logic diagram of a D flip-flop having the D input, clock input, Q and Q bar as outputs. To understand the working of a D flip-flop, let us have the output Q is equal to 0. Then if we apply D is equal to 1 and clock is equal to 1. As D is equal to 1, so that 1 will be the input for the first NAND gate, and here the clock is 1, both the inputs are 1, therefore the output is high. The same D input is connected to the NOT gate, therefore the output of this NOT gate will be equal to 0. That will be the input for the second NAND gate, as one of the input is equal to 0, therefore the output is equal to 1. Here, for the third NAND gate, one of the input is 0, therefore the output which was 0, that will be converted to 1. As one of the input of the third NAND gate is 0, therefore the output will become 1. That means 0 is converted to 1 and this output is 1 is nothing but the D input, that is 1. That is, the output follows the input. So here the truth table is given. So we have seen the case when D is equal to 1, clock is 1, the output D which was 0 will be converted to 1. If it is 1, that will remain as it is. That is, ultimately the output is equal to 1 if D is equal to 1. That is, Q of n plus 1 is nothing but D. Here it is written as Q of n plus 1 is equal to D. So the output of a D flip-flop takes the state of a D input at the movement of a positive edge at the clock pin and delays it by one clock cycle. That is why it is commonly known as a delay flip-flop. So here we can understand this one by using the timing diagram. So here the clock, when it is made 0 to 1, whatever the D is there, that will appear at the output. And this will remain, the output will remain in the same state till there is the next clock pulse comes. So in this duration, the output will remain same. So again, during the positive edge trigger, if D is 1, then the output will be converted from 0 to 1 and it will remain in the same state till the next triggering is there. Again, the next triggering, if D is equal to 1, that means output is equal to 1. Already it is in 1, it will remain in the same state. So here we can ultimately say that the output Q follows the input in the presence of a clock signal. So here this is the delay. That is, the delay is nothing but what? Till the next positive edge triggering comes, the output will remain in the same state even if there is a change in the D. When the next positive edge triggering comes, whatever the D state is, that will appear at the output. So that's why the name delay, that is nothing but D flip-flop. Output follows the input in the presence of a clock signal. Another timing diagram, same, that is, here you can see that arrow marks are there for each clock positive edge triggering clock pulses. So here the positive edge triggering clock occurs. So at that time, if D is 1, the output will change from 0 to 1. Here in the second positive edge triggering clock pulse, D is equal to 0. Therefore, the output which was 1 will become 0 because input D is equal to 0. So in this way, we can understand the D flip-flop very easily. So now we will go for the next flip-flop, that is the T flip-flop. T flip-flop, we can call it as toggle flip-flop. Here is a block diagram of a T flip-flop and here is a logic diagram of a T flip-flop. So It can be constructed with the help of a JK flip-flop. The J input and the K input are connected, and they are connected to each other, and we can call that one as a T input, and another one input is the clock input. So here we are going to have the two outputs Q and Q bar. A toggle input T is connected to common to both the NAND gates. Here you can see this diagram. T is connected to the NAND gate, and the same T input is connected to the another NAND gate as input. The NAND gates are also connected with a common clock signal. You can see the clock signal, and is connected commonly and is connected to a clock. Only one input to the flip-flop called as trigger or toggle input. Then the flip-flop acts as a toggle switch. Toggling means changing the next state output to complement of the present state output. That means if Q is 0, Q will be converted to 1. Or if Q is equal to 1, that will be converted to 0, provided T is equal to 1 and in the presence of a clock signal. So here the clock signal is shown. It is a positive edge triggered and is connected for a T input, and the outputs are Q and Q bar. So T flip-flop is an edge triggered device, that is the low to high or high to low transition on a clock signal of a narrow triggers that is provided as input will cause the change in the output state of the flip-flop that can be seen from this truth table. If the clock is 0, then whatever may be the input of T, that is it may be 1 or 0, there will be no change. If clock is 1, it is shown here clock is 1, but if T is made 0, that means here J is also equal to 0 and K is also equal to 0. J is also equal to 0 and K is also equal to 0. Therefore, there is no change. Therefore, Q of n is equal to the previous state only. Q output will remain same, no change. If clock is 1 and T is 1, then the output will toggle. This we can understand with the example here. Here the output shown is the 0, Q is equal to 0, and we apply T is equal to 1, clock is equal to 1, and you can see it in the truth table, third row. What we have done, T is equal to 1, previous state Q is equal to 0. Now all the inputs are 1, 1, 1, therefore the output is equal to 0. And here one of the input is 0 because it is a feedback which we have taken from the Q. Q is we have 0, we have assumed, therefore here for this NAND gate one of the input is 0, therefore the output is 1. Here for the first NAND gate, as all the inputs are 1, the output is low. If one of the input is low, then the output will convert to 1. That is previous state is 0, that will be converted to 1. That is toggling has taken place. 0 will convert to 1, or 1 if it is there, that will be converted to 0 if T is equal to 1 in the presence of a clock. So this we can understand it more clearly by using the timing diagram. So whenever the positive edge triggering clock pulse takes place, if T is equal to 1, then there is a change in the output. Here you can see that the clock is changing its state from 0 to 1. T is equal to 1. Therefore Q, if it is 0, it will be converted to 1. So in the second clock pulse, the T is 0, therefore there is no change. Therefore previously Q was 1, it remains 1 only. Again during the third clock pulse, T is equal to 1, therefore the output changes its state from 1 to 0, which is shown with the help of these arrow marks. So the output Q will toggle. So here you can see the truth table. 0 will be converted to 1 or 1 will be converted to 0 if T is equal to 1 in the presence of a positive edge triggered clock pulse. Thank you. Thank you very much.